The topic that is chosen is the standard cell library creation. There are three areas concerning standard cell library creation which I'm going to emphasize on. They are mainly Introduction to Standard Cell Library, Standard Cell Library Creation, and Characteristics of Standard Cells. Before going in depth into the creation, we need to know what standard cell libraries are. Standard cell libraries are made up of primitive functions, macro functions, components, memory elements. It is a design abstraction where low-level logic functions are used. For example, AND gates, OR gates, NOT gates, XOR gates. It is also the method for regulating the layout so as to obtain the desired circuit layout with the correct characteristics for use. There are many advantages for using standard cell library, which includes making the cells cost-effective and less time-consuming. They are also able to fulfill minimum speed requirements. They are usually less complex in design, however, it takes up a lot of space. Now, we're going to talk about why are they created. Basically, standard cells are developed to speed up the designing process of the circuit. For example, the time taken to create a LFSR would be shortened if standard cells are used as repeated cells are used. It also allows the designer to scale ASICs from comparatively simple single functions IC to complex multi-million gate devices. After introducing on standard cell libraries, now I'm going to talk about standard cell library creation. Standard cell library creation consists of fixed height but variable width. It also consists of the strategic placement of wells. Standard cell consists of the VDD, VSS or GND. In this, cells have a predefined position and width so that it would allow easier connections between two or more cells. An example would be the VDD will be at the top, while the VSS will be at the bottom of the cell, as shown in the video. Talking about the placement of inputs and outputs in standard cell library creation, it is very important as it would affect the complexity of routing between different cells. For the input and output, there must be a specific layer for the type of metal, position and size so that the additional contacts need not be used to contact different metals or layers together. Lastly, after talking about standard cell library creation, I'm going to touch on the characteristics of a cell in a standard cell library. In a standard cell library creation, it consists of modularity, locality, and regularity. In modularity, modules are self-contained, independent units that can be combined with other modules to form different circuits, which have well-defined functions and interfaces. The interfaces are usually defined by ports and must be specified by specific locations and specific conductors. In locality, sub-modulars that are kept transparent from the parent modules, the internal connections are hidden from the parent module to reduce details at the parent module. Connections must only be done at predefined ports, locations, and external wiring may not be able to be connected at certain kit-out areas. Regarding the kit-out areas, each layer should extend 1/2 of the design rule distance beyond the edge of the cell, and internal elements should be at least 1/2 of design rule inside the edge of the cell. Lastly, for regularity, the design is divided into a set of similar blocks. For example, a 4-bit adder which use similar AND and OR gates are used to implement the design.
I'm a chip head, well I'm a chip head, I'm a chip head.